Okay, just like we can take components and add them up to get a resultant, we can also take a resultant and break it down into components. There are a couple of things to know about this. One is that when you break down a resultant, there are actually an infinite variety of ways that you could break it down. Think about like if you were going to go from our classroom to the restroom, you could take a pretty straight shot. You could go out down the hall, take a left, go take another turn, and then be at the bathroom. Or maybe you want to be out of class for a really long time, so you wander up and down the halls and eventually make it to the bathroom. Either way, if I draw a straight line just through the walls from my classroom to the bathroom, it would be the same resultant whether you wandered around the school 12 times or whether you went straight there. Okay, so that's what we mean by an infinite combination of components. There's just an infinite variety of ways that you could break down a single resultant. You also could put those infinite varieties in any order and the resultant will be the same. So that makes this a little bit complicated. What we're going to do in order to simplify is we're going to resolve we're always going to resolve into two specific components. We're going to resolve into horizontal or x components and vertical or y components. So this x and y is coming from the graphing that we've talked about a lot. Y being a vertical axis and x being the horizontal axis. So our angled one here is our resultant, right? And we're going to break that down into components. And so we want to break it down specifically into a horizontal or x component, and we want to break it down into a vertical component or y component. Notice that my components are head to tail, right? So I started at the beginning of the resultant and I pointed towards the left, and then my next component was head to tail with that, pointed up, and I am ending at the tip of the resultant. So I'm still actually following the same rules as when I added. I'm just kind of doing it backwards. Okay, so a couple ways to solve the triangle. There is a whole video about trig reviewing, and so you might refer to that if you are not so sure about how to do SOH CAH TOA. We also can use Pythagorean Theorem, and we'll work through a couple examples here. So again, if you don't know how to do those, there is a video that is a trig review that you can watch. Okay, so we have here a 100 meter vector oriented 37 degrees above horizontal. So that's a weird wording, right? So what you can do is give yourself a horizon or just a horizontal line. Okay, and then you're just going to eyeball 37 degrees above that. So here's where my 37 degrees is. It might be helpful when you're doing angles to remember a quadrant system where the right side is 0, the top is representing 90 degrees, the left side is representing 180 degrees, bottom is 270 degrees. And then if we make it all the way around again, we're at 360 degrees. So if I'm going for 37, I've got to be somewhere between 0 and 90, right? Down kind of low. So that's how we're eyeballing. Okay, next question says, what are the horizontal and vertical components of a 100 meter vector? So this vector is the 100 meter. It said it was oriented 37 degrees above horizontal. And then I want the horizontal component, which is going to be this one. I'm going to call it delta x because this is a displacement, because my original was a displacement. It was in meters. Okay, and then I also want the vertical components, and so that's going to be that side, and I'm going to call that delta y because this is also a displacement. Again, this 100 meters here, we're breaking it down into its parts. We're not getting something new or different. We are just breaking down the 100 meters into components. Okay, so let's start with our horizontal side. If we're thinking about a triangle, this is my adjacent side because it's touching the angle. This is my opposite side because it's opposite from the angle or across from. And then, of course, the slanted, the angled side is always the hypotenuse. So when I think about SOH CAH TOA, I'm trying to think, what do I have and what do I need and which one will work? Okay, so on the bottom, I have adjacent, or I need the adjacent side, right? I have the hypotenuse and I have the angle. So the one that will work is cosine, because I've got the c, that's cosine 37 degrees. I don't know the adjacent, so I leave that as delta x. And then I have the h, or the hypotenuse, was 100 meters. To solve this, I'm going to multiply 100 by both sides. So it cancels from the right, and we are left with 100 meters times cosine 37 degrees. When you do this in your calculator, make sure that you are in degrees and not radians. And when I do 100 times cosine 37, I get a delta x of 79.86. I'm going to use meters because the original resultant was meters, and then I'm going to put a little plus because I drew that to the right. Okay, so remember, the plus and the number and the unit and the picture are all a part of the answer. You need to have all 4 of those parts. Okay, for my vertical side, I need the opposite. I have the hypotenuse, I have the angle, so I'm going to choose to use sine. So I have sine 37 degrees, that's the S. I do not know the O, that's delta Y, and then the H is 100 meters. I'm going to do the same algebra that I just did and multiply 100 by both sides, and then that gives me a delta Y of 60.18 meters, again because this is a component of the resultant, and then plus because I said it was up, and that gives me my answer for the vertical side. One last example here. Okay, so for this one we have a soccer player running 22 meters south down the soccer field. So we're going to start by drawing that in. I said that I'm going to use my normal cardinal direction, so south is down. So I've got 22 meters here. Then the soccer player cuts 13 meters east, so east is to the right. I want my 13 meter arrow to be visually shorter than my 22 because it's a smaller magnitude, right? And then it says, what is the displacement? So remember, if I'm looking for the resultant, or the displacement, that's the shortest line distance from beginning to end, or from start to finish. I want to begin at the start and I want to point towards the finish. Because I have my 2 sides and I don't know the hypotenuse, I'm going to choose to use Pythagorean Theorem to solve for this. And so I have 22 squared plus 13 squared equals c squared. So 22 squared plus 13 squared is 653 equals c squared. Take the square root of that so that I can just have c, and I find that my displacement is 25.55 meters. I'm going to use, again, the same unit as what were in my original, and then I need a direction. So again, if you struggle with direction, give yourself a little set of quadrants and draw in your cardinal directions, and I see that I'm between south and east, and so I'm going to say 25.55 meters southeast. I do not want to use positive or negative in this case because it is both positive and negative since I'm at an angle, and that won't work. As always, reach out if you need any help and you've got a couple sets of vector practice problems that you can try.